Okay, hi everybody. So my name is Nicolas Gensollen and I'm working with Matthieu Latapy at the Computer Science Lab of Paris 6, also known as LIP 6. And today I'm going to talk about a new cryptocurrency that we are studying with the aim of better understanding the interplays between social ties on the one hand and financial transactions on the other hand. So the outline of this talk is the following. I'm going to start with a small introduction explaining who we are and what we are interested in. And I will have a few words about this cryptocurrency that we are studying and how we're using stream graphs and link streams to study it. And I will give some results in the second section. So who are we? We are members of the Complex Networks team at LIP 6. And we are basically interested in everything related to networks. So it goes from internet measurements, random graph temporal networks, to social network analysis, spreading phenomena, graph algorithms, and so on. So if you're interested, you can visit the website, complexnetworks.fr, in here. And among these members, some of us, like Matthieu and myself, are interested in something called stream graphs. So I'm going to explain a lot about them in the presentation, so I'm not going to focus too much in here. But they are basically these objects that enables you to study interactions over time. So if you're interested and want to know more, you can look at, maybe you can see it, this paper in here that explained the whole framework of the stream graph. It was written by Matthieu and so on. And my specific research focus with Matthieu is basically anomaly detection in large sequences of interactions. So finding basically anomalies in large stream graphs or link streams. And a challenge with this is finding good data sets. Good data sets to validate the anomalies that you find. And in our quest to find good data sets, we stumbled one day across this cryptocurrency. So it's called June, but you write it J1 with a tilde on the J. And you pronounce it June for some reason. And like any cryptocurrency, it enables transactions between members. So it means that you can extract from the blockchain a stream of transactions, so basically a list of tuples, TUV tuples. And each tuple basically means that entity U sends some money to entity V at time t. So we're going to keep things really simple in here. And so basically, you can extract a transaction link stream that we are going to denote by T in here. And it's composed of three things. So a set of time instants that you can see in here on the x-axis. So in this simple example, it goes from 0 to 5. And a set of nodes. So in this case, you have 4 nodes, A, B, C, and D, that are on the y-axis in here. And we are going to keep things simple, so we assume that we don't have any dynamics on the nodes. So nodes are present all the time. So from t equals 0 to 5, all nodes are present in the stream. And then we unfold the blockchain, and we get transactions between members. So for example, at t equals 0, C makes a transaction with B, and we're going to represent this with this arrow in here. And if we unfold, we get new transactions at t equals 1, t equals 2, and so on. Maybe there is no transaction at t equals 3, and so on. And so when we unfold the blockchain, we get the link stream of transactions. And then, so if you query, you can query by node, and you can query by time. So if you query at t equals 1, for example, you get an instantaneous graph. So in this case, you have 2 links, A, B, and DC. In here, you have no links, and so on. Okay? So, 2 things at this point. First, I want to apologize for the drawings. That's basically the extent of what I can do in this domain. And then, so about the nodes in here, in most cryptocurrencies, they are wallets. So they are cryptographic keys that you use to make transactions between wallets. And in most currencies, like Bitcoin and so on, they are anonymous. So it means that people are actually encouraged to create keys to make single transactions. So it means that recurring transactions like this one, they usually don't happen in Bitcoin. So a key property of this cryptocurrency is that they have a mechanism to identify their members. So I'm not going to explain why they need to do it, but they have pretty good reasons to identify them. So basically, in their system, if you are a member, it means that you are a living human being, basically. And the way they do that is through a web of trust mechanism. And the way it works in the blockchain is that they have, in addition to the stream of transaction, they have a stream of certification. So again, we keep things simple. So it's a list of tuple, TUV, meaning this time that member U certifies the identity of member V at time T. So and the way they're doing this is that they meet in real life and they certify each other. And so we extract a certification link stream that we done by C. And it's the same set of times. So in this stupid example from 0 to 5, we have the same set of nodes, so the members of the system. But this time when we get a link, so it's a certification. So for example, at T equals 0, member B is going to certify the identity of member C. And the main difference that you can probably see is that you have this big horizontal line in here. Because in this system, when you give a certification, it's valid for 2 years. So the links have actually a duration. So when you unfold, you get new links, a new certification. And what I'm showing on the top right corner is the aggregated graph of the stream. And it's actually what they call the web of trust. So it's basically the social network behind the currency. So basically, nodes are members and links are the certification links between the nodes. So again, we can unfold the blockchain, we get new certification, and just be careful. So if you query a time instance, so for example, T equals 1, remember links have duration, so you have one link, BC, and same thing at T equals 5, you have 4 links and not 0. So why is this great? So it's great because if you combine the two, it means that you have certifications and transactions. So you actually have a dynamic network of social ties and financial transactions between identified human beings. And it's something that it's pretty rare to have all these things coming together in one data set. Usually you have transactions between anonymous accounts, or you have social interactions, but you don't have the transactions and so on. So it's a pretty good data set to study the interplays between all these things. And so I want to, so maybe instead of results, I want to show you how we can use stream graphs to answer questions. So I'm going to only ask simple questions in here and show you how to answer them. So first of all, I want to focus on the time between transactions and certifications. So for example, if A and B are certified, so they are connected in a social network, I want to know if they made a transaction in the past or if they will make a transaction in the future. And if they do, I want to know how much time separate the certification from the closest matching transaction. And we can ask the question the other way around. So if A and B make a new transaction, are they connected in the social network, or will they connect later? And again, how much time separate the transaction from the closest matching certification, so the social bound. So with our drawings again, it means that if we get a new certification, so this one, for example, A certifies B at T equals 2, we look in the stream of transaction from the closest matching transaction, so it's going to be this one. And we look at the time difference between the two, so it's negative because it's in the past, so 1 minus 2 in this case, so minus 1. And we can do the same thing for transactions, so we consider this one, for example, between C and B, and we look in the stream of certification for the closest matching social tie, which is this one over there, and we look at the time difference, which is 5 in this example. And if we do that for the stream of certification and transaction in the blockchain, we have the following. So I forgot to mention that the time difference can be infinite if you cannot find a matching link. That's pretty important. So it can be negative if the link is before, positive if it's after, infinite if you cannot find a matching link. So if you look at these, basically what you can see is that when you look at the blue bar, you can see that most certifications, so a little bit more than 70% in this system, do not have a matching transaction. So it means that people tend to make social connection a lot, but they don't necessarily make transaction with them. And it's not true for the transaction. So if you look at transaction, you can see that most transactions have actually a matching certification. So it means that people tend to make transaction with their friends rather than with random people. So these two, we can plot the actual values in here. So basically, I'm showing the distribution of delta t values between a certification and the closest matching transaction, and the other way around, so between a transaction and the closest matching certification. And basically what you can see is that usually when you have a matching link in the other stream, the time difference between the two tends to be rather small. So it means that when people meet friends and make a connection, they also tend to make transaction pretty quickly if they will make a transaction in the stream. So I'm going to jump to another set of questions about the reciprocity of the links. So the easiest question we can think of is, are certifications and transaction reciprocal? So if I certify you, do you certify me? If I make a transaction with you, do you make a transaction with me? And how long does it take to get the opposite link? And we can go a little bit further than that and look at more complex questions, like how fast is the money cycling in the stream of transaction, for example. And I want to try to answer these questions using a stream graph concept that is called the K-closure of a link. So it's a measure for links. So this one, for example, and we're going to look at the two closure in this case. So it's defined as the amount of time you have to go back in the past to close a cycle of length k. So in this case 2, so we want to go back to this one because the one at t equals 5 is not in the right direction, you have to go up. And it means that in this case the 2 closure of our link over there is equals to 4 because it's 6 minus 2. And we can do the same thing with the 3 closure. So we want to find a triangle in the past. So it's going to be these 3 links, and then the 3 closure of the link is equals to 5 because it's 6 minus 1. And if you compute those values for the streams, so in the upper plot, you have the distribution of 2 closure values when they're not infinite. So when you can close the cycle of length 2. So when the interactions are reciprocal, they tend to be reciprocal pretty fast compared to the duration of the stream. And for comparison, I showed on the bottom plot the distribution of the 3 closure values, so the time it takes to close the triangle in the stream when it's not infinite again. And again, it's pretty fast, so it means that the money is cycling pretty fast in this network. So I'm going to jump to the conclusion and takeaways. So this, we believe that this system offers a unique data set to study the interplays between social ties and financial transactions. And since it's basically composed of 2 streams, we believe that stream graphs or link streams are good tools to study them. And a few takeaways specific to this cryptocurrency, which is still young, but very interesting, is that members tend to certify people they never make transaction with, but they tend to make transaction with people they're socially connected to. And when an interaction occurs in both streams, there's a clear time proximity, so they tend to be close in time. And finally, yeah, interaction tend to become reciprocal in short periods of time, as we just saw before. And with this, I'm going to jump to the questions. So if you have any questions, feel free to ask them now or later in the conference. You can send me also an email. And if you want to find the slides, they should be pretty soon on this GitHub when it's public. Thank you.
Yes, that's interesting. So you know that there is a transaction, but you don't have the amount.
You do have the amount. So I said I'm going to keep things simple in this talk.
Okay.
So
I think it would be interesting.
yeah, I agree. Yeah, I agree. So usually you have the amount in the blockchain, of course. Yeah.
Okay.
So
you don't use it for now.
it depends. For this, no. But you can use it, of course, because it's not the same thing to have a triangle where you have 100, 101, or 100, 100, 100, or something like that. Yeah. We are actually working right now with using these weights.
So just a clarification, I'm not sure I understood. So the social connection, is there an incentive? What's the advantage of someone forming that connection? Since they can have transactions without.
So you can make transaction without. So basically they have two kind of accounts, so member accounts and anonymous accounts. And if you are a member, I don't want to go too much into details, but it means that you receive every day some amount of money, basically, like universal revenue. And so you want to make sure that the people who create these accounts are actually real people, because otherwise I can create as many accounts as I want, and I receive a lot of money. So the way they do that is that they actually meet in real life, and they build this web of trust, and they assume that the denser it is, the safer it is. So that's why they make these connections. And to become a member, you have to enter this network. So you have to get I think it's 5 connections or something like that to be able to enter the network. So right now, the cryptocurrency itself is pretty young. So it was created in 2017. So it's only 2 years old. So it's not really big. If you look in terms of numbers of members, so not accounts but members, you have about 2,500, something like that. So pretty small. And number of links, I don't know, but a few tens of thousands. So yeah, even with not optimal algorithms, you can compute triangles and so on for now.
Other question? I have one question. Why did you choose to work on this cryptocurrency?
What?
Why did you choose
Oh,
to
why
work
did
on
it?
this one?
So, as I said, I'm working on anomaly detection, and since you have the community, like they're all French, so you can actually, when you spot an anomaly and say, oh, there is something weird in here, you can actually go and talk to the people, say, what did you do to this day? And say, oh, we were having a drink and we made some transaction between us, so that's why you have triangles and so on. That's why we did that, but we have some problem with this because the stream is pretty sparse and people tend to actually make transaction only during events, so it's, but that's the reason yeah.
Okay, thank you.
Yes, the last question. So, about this cryptocurrency and about your method. If I understand correctly, you need to meet 5 persons to be in the group, and then you will receive some coins every day, let's say. So, I imagine that some people will try to fraud. You can have a group of 5 people that creates a bots, and they just a lot of bots, and just validate, 5 people validates the bot, and they have a lot of money. Can you use your framework to detect this anomaly, detect this fraud?
So it's funny that you mentioned that because it's something I want to do. I'm really interested in this. So they have a set of rules to avoid that. So it's not only 5 connections, they have also a rule where you have to be close to special nodes in the network to avoid having a cluster of Sibylls forming. But honestly, I don't trust them because a lot of thresholds are equal to 5 or stupid values like this. So I think they just decided to put some values, some random values. But having someone like actually working on this and finding if an attack like this is possible or not, depending on the parameters, is something I really want to do, for sure.
Yeah, I think that these things
Mm.
can be applied.
Even using like classic static graph, I think. But yeah, definitely want to do it.